6 vectors A through F have the magnitudes and direction indicated in the figure. 6 vector. This is A, B, C vector, D vector, E vector, F vector. Which of the following statements is true? Do you know what is meant by independent? Independent. Independent means any change in one variable doesn't affect the other variable. Then it is called independent variable. Suppose I am taking two variables. One is along x-axis, another one along y-axis. Here, the velocity is here. This is the mass. It has a velocity of 5 meters per second along x direction. The same mass has a velocity of 10 meters per second along y direction. Suppose I am giving force in this direction. Because of that, the 5 is changed to 7 meters per second. I gave additional force. That's why the speed along x direction is changed from 5 to 7 meters per second. What is the change? 5 to 7. Because I gave additional force on this mass. That's why its velocity along x direction changed. Is there any change in velocity in y direction? No. Because the angle between x and y is 90 degrees. If the direction is 90 degrees, they are independent. This is mechanical property. That's why we are taking the axis, x-axis and y-axis at 90 degrees. Any change along x direction will not affect y direction. Any change along y direction will not affect x direction. They are independent. That's why they are called axis. Why it is called x-axis, why it is called y-axis. Suppose I am putting this way. Here I am putting this way, x-axis. I am saying this is y-axis. I can say x-axis. I cannot say this as y-axis because y and x are dependent. Any change in x will affect y. Any change in y will affect x. They are not 90 degrees. That's why x and y are not axis at all. If they are 90 degrees, then only they are called axis. That's why for 3-dimensional, I told on the day the example that the room corner, bottom corner, I'm having one wall in front of me. That this is the ground, this is the ground, and this is another wall, side wall. This wall is in front of me. This is the ground. This is the ground. So this in the front wall and ground meeting, that is x-axis. Two walls are meeting, that is y-axis. The 90 degree between x and y is there. The side wall and ground is meeting, that is z-axis. If you see z and ground, the side wall and ground, they are 90 degree. If you see x and z 90 degree, y and x 90 degree, y and z 90 degree. That's why they are called axis. Otherwise, they are not called axis. You cannot call. Time also have one more axis. Suppose the 3-dimensional you are talking means how many dimensions? We are in 4 dimensions. We are in 4 dimensions, not 3 dimensions. We are in 4 dimensions. Time is one more dimension. Time is independent. No one can stop the time. Always it is running. You cannot stop it. X cannot stop. T, Y cannot stop. Z cannot stop. That's why that is also Independent means T is orthogonal to X. It means it is 90 degree to X. T is 90 degree. If you take time axis and X axis, if you take time axis and X axis, it will be like this, 90 degree. If you take time axis and Y axis, it will be like this. If you take time axis and Z axis, it will be 90 degree. That's why if you take a horizontal line as X means vertical, we are taking Y, we are taking Y deliberately because we used to say this Y. That's why you can take X also, you can take Z also, as you wish. You can take velocity. You can name it this vertical axis as velocity axis. You can name it as displacement axis. You can name it as acceleration axis, but time axis is horizontal. They are independent. That's why 90 degree. Wherever two variables are independent, it should be represented in 90 degree out of phase. So A and D are independent. A and E are dependent. They are not 90 degree. A and B are independent. A and C are dependent. A and F are dependent. Now, what is the vector? What is the vector sum? A vector A is going like this. Vector will be represented like this. A bar. A cap. We should not say cap. I will tell later. A bar. This is A bar and D bar. This is D bar. If we add A bar and D bar, let us assume that this is this much magnitude, this is this much magnitude, means if you add these two, this vector will be like this. A plus A bar plus D bar. A bar plus D bar is depend on A as well as depend on D. But A and D are independent. One vector is going like this. Another vector is going like this. Which two can be taken? D is like this. E is like this. So the magnitude of E is this much. Magnitude of D is this much, means these two are independent. E and D are independent, 90 degree. But if you add these two, you will get a vector D plus E. D plus E. This goes this way. On the other hand, if A is this way and D is this way, then if you add these two, what you will get is, you will get a vector A plus D bar like this. Suppose I am having, so one is downward, this is towards the right, then A is this way, B is downward, then the sum of these two is A plus B. A plus A bar plus B bar. So what is asked in all, they are adding two vectors. But the answer is F only. F means one must be this way, another one must be this way. So this way means we have to take E. This way means we have to take D. Therefore, D plus E. Therefore, C is the answer.